Good morning, my name is Castro and welcome to Inside the Classroom. Today, in my classroom, we're going to talk about the concept of a right triangle as it pertains to a gable roof. We're going to use the Pythagorean Theorem to figure out the length of a rafter. Come and join us and welcome. Good morning, how's everyone doing? Good. Today as a pre-class activity, you have in front of you a sheet and I want you to take about 4 minutes. We have about 4 minutes and I want you to figure out the missing value. I want you to find out the area and the perimeter of this triangle. Let's take about a couple of minutes, 4 minutes to get this accomplished. If you have any questions, you can help each other. This is an opportunity to show me what you know. This is not for a grade, so I don't want you to feel nervous. If you are ready, please place your pencil down so I know that you are ready. Okay, let's continue, guys. We did it under the 4 minutes. Excellent work. Now let's continue with our lesson. Okay, the reason why we did this as a pre-class activity, we were calculating the area and the perimeter of a right triangle. And for the missing value, which formula did we have to use? Well, that's for the area, yes. But for the missing value,
a squared plus b squared equals c squared.
which is called the Pythagorean Theorem. And we're going to see today how that's going to play a big role in designing buildings, designing structures, designing roofs, and designing pretty much anything. We need to find out, we need mathematical equations, okay? And then we are going to turn this into a three-dimensional drawing, okay? So for the pre-class activity, I want someone to come up to the board and give me, okay, someone, I need a volunteer to come up to the board and figure out the area of that triangle. Come on, Josue. Now you have to start thinking now. I want you to figure out now in your mind as he's doing it to make sure that he's doing it okay. And also, I want you to start thinking about the perimeter. Figure out the perimeter of that triangle. Okay, so if you can please explain what you're doing to the class.
Okay.
And come on this way so you're not, okay.
Okay, so to find the area of the triangle, it's basically length times width divided by half. Because the triangle, if I connect it like this, it would be like 1/2 of the triangle. That's what you're solving. So you do the length times the width, which is 8 times 6 equals 48. Then you just divide that by 2. Divided by 2, so the area will be 24 and square feet.
24 square feet.
Square feet.
Okay. Is there anyone here that has any questions regarding this? Pretty simple, right? Now, thank you, sir. Have a seat. Now, the perimeter. We figure out the area. What is the perimeter? Perimeter is what?
All around.
All around. But we have a missing value here. How can we come up with that value? Come up, sir. You're the winner. And please explain to the class as your...
Pythagorean theorem is a squared plus b squared equals c squared. So first you gotta do a squared, and a equals 6 foot, so you do 6 times 6, which equals 36. And then you do b squared, which is b, so it's 8 times 8, so 8 would be 64. You add them both up, you get 100. And you get the square root of 100, which would be 10. So C equals 10.
10 feet?
Yeah, 10.
Mm-hmm.
And then after that, you find the perimeter, and then you just add all the sides up, which would be 24. So C equals 24. That's perimeter.
24 square feet. Good. Is there anyone here that has any questions regarding this? Now, excellent job. Now, what we're going to do is we're going to see how this plays a big role on the design of buildings. We did an excellent job, but the question is, how does this apply in real life? What do you think? How do you think this is going to apply in real life? Because you see this on tests all the time. How does it apply in real life? Does anybody want to share? What do you think you're going to need this for? Do you think engineers are going to need this?
Yes.
Do you think a carpenter is going to need this?
Yes.
Okay. Do you think an architect is going to need this?
Yes.
So regardless of what you choose to do, you're gonna need mathematical equations, right? You're gonna need to figure things out. Okay. So we're going to apply the concept of a right triangle to a gable roof. We're going to find out how does that work. We're going to calculate the length of the roof rafter. The roof rafter is the portion of the roof that protects you from the elements. So if I ask you to figure out, or if you're building a house, if you're designing a house, and I ask you how long does that piece need to be, what do you think you're going to use?
Pythagorean theorem.
The Pythagorean theorem. You're going to figure out the run, the rise. You're going to see the run, the rise, and then figure out how long that rafter needs to be. Okay, looking at a diagram here. The total span is the span from the outside wall to the outside wall. So if you think this as being a house here, we have the walls here, the walls here, and then we have the roof as such. Everybody understands that, right? Now, if the span here is 24 feet, what would be the run? 12 feet. So now you know that 12 feet would be that portion of your triangle. Okay? And then if you have the rise being 5, you can figure out now what?
The Pythagorean theorem.
Which is the roof rafter that we're talking about, right?
Yeah.
Now you have an employer. Let's say you're designing a house, and you design these roof rafters to be too small. Now you have a problem, right? So we need to know, we need to make sure that we are calculating the rafters, or the length of the rafters correctly. Okay, we have the unit rise and the unit run. The unit run, when you design a roof, is always 12. And this determines, the unit rise determines the pitch of the roof. So you can have a roof that is a 5 and 12. You can have a roof that is a 3 and 12. You can have a roof that is a 6 and 12. Okay, and that's the only thing here. The unit rise is what is going to be, can change all the time. The unit run always stays 12. Okay, and always remember, on the right triangle, this side, the hypotenuse, which is called the hypotenuse, right? The longer side. The hypotenuse is the longest side of the triangle. Now, you have another sheet in front of you. And I want you to take about 3 to 4 minutes. And this time, I want you to figure out, again, what is the roof rafter, the length of the roof rafter, by using the Pythagorean theorem. After you do this, we're going to jump right on the computer, and we're going to design it. Okay? So take a few and do this. If you're done, place your pencil down. Okay. Now, who wants to be my volunteer to come up to the board? Mr. Pagan, what do you think? And as you do this, Mr. Pagan, I want you to explain to the class what you're doing and tell me the length of that rafter, of that roof rafter. Because you have to cut it now. You have to make sure that you have, go ahead.
But first, you gotta multiply. Then, they gotta do 15 times 16, which is 256. Then you add that, which is 400. Then you square it with the 400, put it on another 20.
Go ahead, finish it.
C to the square root equals.
What do you think? What do you think, guys? He's right?
Yeah.
Absolutely, he's right. You can have a seat, sir. Thank you. Always get into the habit of, thank you. Always get into the habit also of writing the formula out, and then placing the value, substituting if I have a squared plus b squared equals c squared, make sure you write it first, and then you put the values in. Okay? It makes it a lot easier. But you did it perfect. You did a beautiful job. Thank you. Now, what are we going to do now? We have a project that we have been working on. What have we been working on for the past, let's say, containers? Now, tell me about those containers. What are they and why are we doing this? Okay, shipping containers. Tell me what they are and why we're using them in our designs.
Well, we're used to it because people are just leaving them. They're moving.
They're being abused, and there's so many out there in the world, and like
They
people
get
just
lost
throw them
out.
away. There's even shipping containers underwater
Yep.
that people don't use them a lot.
A lot of them
And
get lost overseas.
We're using them to kind of like not use that many other materials or resources, so we're like recycling basically and making houses with them.
Very good. We are recycling these containers to create structures where people can live and can work. Okay? Now we're learning about sustainable architecture, green architecture. Now we're going to place all this together now, and I have a similar project that you have been working on, and I want to put a roof on it. I want to put a roof on this house, on these two containers that I have together, and I want someone to come to the front and show me how this roof can work. I want you to figure out the rise, the run, the pitch, and I want you to create that roof. Mr. Levine?
Yeah.
As you're doing this, Mr. Levine, can you please explain?
Alright. I suggest we use 5 and 12 for this one. Yep, that would be correct. So first I'm just gonna hit here and press line, or type it, whichever you prefer. And we're gonna go 5 inches up, then 5 inches to the side here. Just making sure you can see. We're gonna go 12. And then we're gonna hit C to close it. Now we're gonna do this on the other side also. I'm just gonna type here mirror. Gonna select these points. And I'm gonna select the midpoint of this wall here. And click. And there we go. We have it on this side now. Now what we need to do next is we'll fill it. And what this does is it basically connects this line and this line together. So now we got basically the base of a roof. And we're gonna go ahead and hit 3D face. We're gonna go ahead and type it, 3D face. So here we're just gonna select this input right here. Select this one, and then we go back to this one, close it. So what that created was a simple base roof where we can just hit press pull, and basically when it selects it here, we can and just press pull it across the whole house until the other end. Then we can erase these because we don't need them anymore. What I like to do is I like to just, to make it clean, I like to just move it up a bit. Set it like here. And then just erase all this stuff to make it more clean. And we just move it down. And that is our room.
Excellent, excellent. You can have a seat, sir. Thank you. So we noticed that he just took that same profile of that triangle. He drew the triangle as such, and then he gave it 12 inches, that is constant all the time, right, for a roof. And then the one that changes would be, you gave it a 5 if I'm not mistaken. So he has a 5 and 12 roof. If he wanted to make this 6, what would happen to the roof?
It will increase.
It will be steeper, okay? So this really determines the pitch of the roof. Now, everyone, what I want you to do is I want you to have your projects in front of you if you haven't already. I see already Carlos have done it. But I want you to figure out the pitch of the roof, and I want you to come up with a gable end. Take a few minutes right now and take the opportunity to draw that triangle at a 5 and 12 pitch, and have it on both sides like Mr. Levine did. And I want you to fillet those two to create that gable end. This simple house that we did here, or the roof that we did for this simple house, I want to be able to move around. Now I want to be able to see all different angles of this house. How can I accomplish that? How can I go around and show all sides of the house as an orbit?
We can use orbit, or we can use that little box there on the side where it just says the size of the house, how bright the viewport.
We can use that. We can have it as viewports. Chris, do you want to come up and show us how to orbit this around? Just type orbit and just go around and show me, just show me all sides. That's all you need to do. I want to be able to see all sides of this house so we can appreciate how the house looks in all angles. Enter. Very good. Now orbit this around. Just show everybody around. Okay, a very simple command that will show you in 3 dimensions how this is going to look like. Okay, very good. Have a seat, sir. Now, do you think that we can figure out now, just by using the computer here, we can figure out the distance of the hypotenuse and the distance of the run and the rise?
Yeah.
But what we did first is what? We created this computer here first, and we strengthened our brains, right? We figure out, now we double check with the computer. First, we check with ourselves. We want to make sure that this works. And then once I see it in the computer, I'm able to determine whether this is really working or not. So what happens if I came up, let's say this here came up to 13 feet, but in my calculations, I came up with 30 feet.
Either one is wrong.
One of them is wrong, right? So you have to go back and check. Okay? So the first thing that I always tell you, your computer is here first. You have to first understand and be able to work it out and know whether this computer, what is showing you, is right or wrong. And if the computer is wrong, it's because you put the information wrong. So you have to go back and check your calculations. Okay? What did we do when we first started here, when you first started with me here? What did we do here? What did I make you draw? What's that? The room, the classroom. Why did I make you sketch the room first by hand without using any computers?
To have an idea of how.
To have an idea of space, right? Of distances. So if I ask you right now, what is 3 feet? What would you say?
3 feet.
3 times.
I see everybody looking down on the floor. Why?
3 tiles to one tile.
3 tiles. What happens to the tiles? How big are they?
1 foot.
VCT tiles are typically 12 inches square. So if you count this, you would say, okay, it's about 3 feet. Now if we talked about the roof being 13 feet, now tell me how far is this roof rafter? From the wall. From the wall. Jose, come up here. Tell me, from the wall, stand where this roof rafter is. How far it comes from the wall out.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right here.
It's about right here. So the rafter that we just designed for our house is 13 feet. So it's for about from the wall right here. So that means the total span would be another 13 feet going in the opposite direction, right? And you know now the more or less in your mind you can understand space. All right, so now we have seen, just to kind of wrap this up now, we have seen what project that we have worked on. We have seen how we can use math to make our designs. We have seen how we can design the length of our roof rafters by using what?
Pythagorean Theorem.
The Pythagorean Theorem. And we have seen how we can design that as designers, as architects and engineers, how we can take all that knowledge that we just have in our brain and use the computer as a tool. We can't rely on the computer all the time. We have to have the computer here first. If we make it here first and we understand, then we can use this as a tool. Okay? Are there any questions regarding any of anything that we went over today? So we're good when we take our test. We're just going to go and design all these roofs. Yes?
I want to ask about our house is going to have solar system.
We are going to start introducing, as part of our green building, solar panels. Yes?
That's going to cost more.
Yes, you are going to spend more in the beginning with panels, but then you're going to save with all the energy that you're going to collect from the sun. So is it a good trade-off?
It kind of is, because it keeps paying off.
Mm-hmm.
The sun never runs out on this.
It's a renewable material, it's a renewable resource, right?
Yeah.
So the sun, we can continue to use the sun to produce, use the solar panels to produce electricity for the house. Okay? How are we going to place the house to get the most from the sun? Facing which? North, south, east, or west? If this is your house here. Okay? What is north? North would be this way, right? South? This would be what? And this would be?
That's what.
The sun rises in the?
East.
And it will go this way, right? To the?
West.
This is your house. Which?
You're looking at it from the top, right?
Yeah, we're looking at a plan view. Which side of the house is getting the most sun?
South side.
The south side. The south side, it takes all of the heat. The east will get some in the morning. Does it get any in the afternoon or in the evening?
Yeah.
No.
You're going to get the west side.
Oh yeah, west side.
But here on the south side, are you going to get this?
Yeah.
Completely from beginning to end?
Yeah.
That's what we place it in the south. And if you have your house on elevation here, the sun would be hitting this side of the roof first. Everybody understands why? We're going to cover this in more detail.
We get the base.
But you have an understanding why we're going to place it on the south. All your solar panels would be here. Is going to help me any to have solar panels in the north side? Right now, this is the north side here.
Yeah.
Why? The sun is not hitting it, so it's just a waste.
What about when the summer comes and the sun goes really high?
Depending on in the summer, what's going to happen is if this is our home, this is our house, and I'm looking at this in elevation or section, in a plan or elevation? Elevation. If the sun is here, the altitude of the sun in the summer is going to be where?
Higher.
Higher. So the sun is going to be up here, right? And the winter is going to be where?
Lower.
Lower. So what happens is in the winter, you want, because the sun is lower, you want the sun to come in. We would have our roof rafters that we just designed. Make sure that the overhang is far enough so in the summer, we don't want the sun. So that roof rafter that we designed today is going to protect us from the sun. In the wintertime, we want the sun in, right? We want our homes to be a little warmer, right? So as the sun is lower, the altitude of the sun is lower, then the sun will be able to enter into your home. So how big the windows that we're going to design is another lesson. How big these windows need to be. How high do they need to be? What floor material are we going to use here to collect that energy from the sun so at night it can release that energy?
Can you say concrete?
Concrete, yes. Concrete, we can use tile. Is carpet going to help?
I don't know about that.
Carpet is not going to help too much, is it?
No.
Okay, so we're going to talk about materials, but that's a different class. We're going to talk about materials. But now we did the first step. The first step is we're designing the roof rafters. Why? Because we need to know how far they need to go, how much of a span they need to be. They need to have away from the wall, so we can protect the house in the summertime. As you can see, today we learn how mathematical equations play a big role in today's workforce. Thank you for joining us in today's classroom, and have a great day.